y0z, all of that's to the 3/5 power. What do you think, Michael? Okay, so that makes the x have
the x would be a 12
y.
Y would also be y to the negative 12 this. Oh, I can put x out. So she needs 6 this then.
There we go. Okay, and then z,
Would be 18 this.
and then on the bottom, does the 32 get the exponent?
32, you take the 5th root of it.
Yeah. So when you're taking the 32 with the 3/5, so it's really the 5th root of 32, and then that's cubed, so we'll just rewrite it right there. X would be,
That was also 6 fifths.
yep, and it's negative. And then what happens with the y?
The y is not there.
Yeah, it's not there because it's equal to 1, so it's gone. And z?
Z was 3. I think 3 fifths. That's what happened.
So somebody asked me in the previous class, could you first move the variables to make them positive? Yes. Like there are many ways to solve this. So you could move the y down first and the x up first. You could combine your variables together first on the inside. Like you could work on the inside of the parentheses first and then do the exponent on the outside. So there's not like one correct way to do it. A couple of different ways. So you can combine stuff inside. I mean, generally when we see parentheses, we usually work on the inside of the parentheses and then go to the outside. But there's exponents as well, so you can distribute the exponent through. So kind of just what you are comfortable doing. So Brandon, if we combine our x's together, because this one goes to the top, you get x to the 12/5. How about the y?
It would go on the bottom as 12 fifths.
Yep.
But there would be an 8 in front of it because on the 5th root of 32 cube is 8.
Right, so the 5th root of 32 is 2. 2 cubed becomes 8. And then the z's, Brandon?
You do 18 fifths minus 3 fifths because they're division, so it would be on the top z cubed.
Nice job. How are we doing now? Are there questions from the homework that you would like to go over? Did you make a mistake? Did something wrong? Check all those exponents. You see it? Yeah. So today we are going to simplify rational expressions that are being multiplied and dividing, like with multiplication and dividing, two expressions that are being multiplied or divided. I like doing these because there's always like a whole bunch of stuff that cancels, so you get this huge expression and then it goes down to little thing. There's also factoring involved, so I mean if you like factoring, these are good problems too because there's some factoring involved. In order to simplify when you're dividing expressions or multiplying expressions, if there is a quantity, the quantity is 2 or more terms, you need to have them in factored form in order to cancel. When you can cancel diagonally, you can cancel vertically. If there were 3 terms, you could cancel the first fraction with the last fraction. They don't have to be next to each other, but it must be in factored form. So the bottom left, or the bottom right, what would you do to get that in factored form? 7 minus 21. 8. Yeah. So factor out of 7 and you get 1 minus 3a. And you can factor it right underneath. Unless you really want to rewrite it again. And then you cancel. So again, diagonally or vertically. So Libby, what's one thing that could cancel out?
You can cancel off the 7.
Yeah, so that's like cross canceling. The 7s, what else?
You can cancel out the a squared and
Yeah. A squared. What about the b's?
you can cross out the b squared and that would just be on top.
Right, just a b on the top. So the 3 would be left with 1. Is there anything else that can be done, Libby?
You can cross out, it's like 8, I think. Yeah.
Yeah, so the 24 and the 32 reduce. They don't cancel, but you can reduce them. And if you divide by 8, Libby, you're left with
Wait, hold on.
24 divided by 8.
Yeah. 6. Yeah.
3. 34. 2 divided by 8 is 4. Then after you're done canceling and reducing, look to see what you have remaining and go across the top and grab everything that's left. So starting with the number, we have a 4, and then a b and another b make b squared. So you're just kind of pulling together everything that's left on the top, multiplying those pieces, the 2 b's become b squared. On the bottom, I have a 3. If I had another number, I would multiply it, but I don't, so we just have a 3, and then we have that quantity that we factored remaining. The last thing before you move to the next problem, just do a quick check. Look to see whatever you have written as your answer, does it have anything in common between the numerator and denominator? Sometimes you might miss something, especially if they get bigger. So we don't have any terms in common, they're in 3 and the 4, can't reduce, so that we're good to go. Questions? So if you look at the next one, this one didn't really involve a lot of factoring. The next one definitely has a little more factoring with it. The first denominator here on the left side, I'd suggest thinking of that as the negative 5v plus 25. The v terms are all in the positive, like they're, in the front of it, so kind of thinking that as being in the front of the two terms. Generally, that's where a variable means, so that when you're factoring it, you think about pulling out that negative 5 with the variable. So factor first, and then cancel any terms that they have in common. What could you factor out of the top left? 6b? And how about the bottom left? Yeah, let's take out the negative 5, so that once you have it in parentheses, the v is positive. So taking out a negative 5 gives us a positive v. It was a positive 25, taking out the negative 5 gives us a negative 5. So v minus 5, since you're pulling out the negative. Do you know how the trinomial would factor? The two numbers multiply to make 30. Five and 6. There we go. So 5 and 6 make 11. V minus 5. V minus 6. I feel like I should bring home some of Addie's old multiplication minute tests. I keep those extra ones. I mean, they're good to give around the summer. So after you factor Virginia, then what happens?
We cancel, so the v minus 5 cancels.
Okay.
And then you can take out 6b from the bottom.
Yeah. So this becomes 2. The v is now a 1. Can you cancel the 2v minus 6s on the top? No, because they're both on the top. So if there are 2 left on the top, Virginia, you would say that that quantity would be squared, yeah. So instead of writing it twice, it's one quantity that's the same, it's squared. That's that repeated linear when we were doing those partial fractions. And then on the bottom, there's a 2 that's negative. Just be careful, there is a negative sign there. There's also a negative 5, so that turns into a positive 10, and then v. So just be careful, you're like looking at that negative and making sure you're grabbing all the signs as well. Any questions? So the third one switches to division. What do you do with division, Brandon?
You multiply by the reciprocal.
Yeah, so, and that's whatever follows the division sign. So you're taking the reciprocal of the fraction after the division sign. That's the part that you're flipping, not the first one. So the first remains the same. If it follows the division, division changes to the reciprocal of whatever's after it. All right, Chelsea, this one looks good. What do you think of the the numerator there on the left?
Well, you gotta take 5 out.
Okay, so start with a 5. No other variable?
No.
Can it factor any further?
Is it? I think square triangle.
So I see what so the 9 you're thinking you could take a square root of?
Yeah.
What times what makes 9?
3 times
Would 3 times 3 add?
no.
Yeah, no. So you're thinking on the right track, but there's the 2 3s, that have to be a 6 in the middle for that to work. It actually doesn't factor any further. So looks like it could because the 9 is a perfect square, but 3 times 3 added together would give us 6, not the 3. Chelsea, how about the bottom?
You could take out a 3z.
3Z. And then you would have
3z plus 1.
So then when you go to do the next fraction, make sure that whatever in the denominator moves to the numerator. So if you look currently at what is in the denominator there, because that's what's going to go to the top, how would you factor 9z squared minus y squared, Chelsea?
3z minus y plus or times 3z. So
Yeah, so that's that perfect square, difference of 2 squares. And then looking at that last part, thank you. You too. So this is what's currently in the numerator. Chelsea, is there anything you can do with that first?
factor into
Yeah, so if we pull out a 2, that's y cubed minus 27z cubed. So we pull out a 2. Brandon, what do you notice?
It's a perfect cube.
Perfect cube, yeah.
So you
So
have to do the soap formula.
yeah. Of course, that always comes back to haunt you, just like the quadratic formula. None of those today, no quadratic formula. But this is that SOAP formula. So just if you need a reminder, it's A same sign B, A squared, opposite sign AB, always plus B squared. That's the pattern. So AB, A squared, AB, B squared. Your A term is the cube root of y cubed, that's just y. The B term is the cube root of 27z cubed, so that would be 3 and z. So that's what you're using to fill in the pattern. So this is a pattern factoring, just like the perfect square is a pattern factoring. So these are perfect cubes. So Brandon, what would that look like then?
Y minus 3z times y squared plus 3zy plus 9z squared. And
So pull it out of 2, and then we factored it using SOAP. So Brandon, what do you notice about that second part?
the second part.
Yeah, this part right here. Can we factor it? No. But is there something else identical to it in the problem? Yeah, the first one. So that first piece was there for a reason, because whenever you use the SOAP method of factoring, that second quantity that you factor is always prime. It will never be factored anymore. So that first part and the last part of the factoring cancel. So that's why it was there initially, so that it cancels with something. So if you just continue to cancel, Kayla, what else cancels?
Well, you can pull out a negative sign out of y minus 3z, and then you can cancel that out from the top.
So she's looking at, God bless you, this bottom piece here. So the top has a 3z minus y. The bottom has the exact opposite, y minus 3z. So the y's are opposites, the z's are opposites. When that happens, if you pull out a negative from that, then it becomes exactly the same as what we have on the top. So that would become, if I'm dividing by a negative, I now have a negative y, and a positive 3z. That's what factoring is really doing. Factoring is dividing by what they have in common. If you're pulling out something they have in common. So when you pull out the negative, then the 3z minus y cancels. So if they look identical but they're different by signs, then you can just take out a negative value. And then Kayla, the other quantities that cancel?
3z plus 1.
Yeah. So the only thing left on the top is a 5. And on the bottom is a negative 6, and I'm just going to pull the negative outside, and then the z. You shouldn't really write a negative in the denominator. It's considered unsimplified. So either place it on the top or place it on the outside.
It's very complicated to write negative 5 divided by 60. The original problem.
Oh, yes, a very complicated way. Yeah, that's why I like them. They're huge, and then it's a little bit. So the last one, see if you can get this one to factor. It has division, it's 3 terms. The only thing you're switching is the last term because that's the part that follows the division sign. There are 2 division signs, then the 2 fractions that follow would be the parts that you're taking the reciprocal of. Kate, how would the x cubed minus 27 factor?
It's x minus 3 times x squared plus 3x plus 9.
And then the 4x squared plus 12x plus 36.
I factored a 4 first,
Okay.
and then I got x squared plus 3x plus 9. That's the square of the x.
Good. So cancel away. Those guys are at the end. They both cancel. We have the x minus 3 cancels. And x minus 2. Just working my way over x plus 3. And the next. Anything else?
The 4 and the 2 is simplified to 1.
Yeah, there we go, 2. So the 4 and the 2. So the only thing left on the top is a 2. The only thing on the bottom is x minus 1. Question. Friend.
You should create a problem where it's just all that, but then like find the limit at x versus.
Oh, yeah.
Why would you do
Well, she
that?
already has the test made.
That would be a good problem to put on though.
Don't ever do
Bonus.
that.
Maybe next year.
Oh, maybe
I want you to come to the kids next year.
What?
I gave
Yeah,
Miss,
I don't even know if I'm
I-
teaching the class next year.
I gave Miss Biscuit I was
Sneak
giving Miss
myself a
Biscuit
note.
a bunch of really good problems, and he's like, well, I might have to use those.
Yeah.
Do you hate the kids in next year's chemistry?
Yes, I do.
All right, so if you look at number 22, 22 is a really nice looking one as well. Yeah, look at number 22, all those terms.